So my name is M. Scott Veach. The channel is called Vini Vidi Vici. Translates to I came, I saw, I veached. Anyway, I've been watching Anthony Riley's Flat Earth debates, and he's had Nathan Oakley on as a guest pretty much every day for the last 2 weeks. And Nathan's going on and on and on about this R thing. And I figure, okay, it's, you know what? I've got to address this. I genuinely believed that this guy was going to be able to figure it out on his own. But I have come to realize that it's simply not going to happen. He's going to need help. I'm going to give it to him. What they're saying, their argument is basically that we cannot assume R in the metabunk calculator because to assume R is to beg the question or to have some kind of circular reasoning. Now, they're wrong, which probably will surprise them. If I was on the show, they'd mute me right now and start screaming. This is why they never realize that they're wrong, because they never actually listen to anybody explain why they're wrong. The mistake they're making is they're forgetting what the calculator is telling them. Let's think about this for a second. If you had to put in English what the calculator is doing, what act it's performing, what would you say? Something like, if the Earth is shaped the way mainstream science says it's shaped, then we would expect the world to appear in this certain way, where this certain way is the whole bit about an object at a certain distance from an observer has a certain amount obscured by the curvature of the Earth. But let's just shorthand that whole thing as it looks a certain way. So what's going on here? You assume R in order to generate a prediction. And this prediction says, if your R is correct, here's what you should expect to see out in the world. Now, if what we did was stop right there, just take the prediction, hold the prediction up and say, aha, the world is a sphere. Look, this prediction says sphere. If we did that, then Nathan would be correct. He'd be correct to say that we're begging the question. He'd be correct to say that this is circular reasoning. But that's not what we're doing, is it? That's not what anybody is doing. What we're doing is we're taking the prediction, then we're going out into the real world, and we're actually observing from the point of view of the observer, looking at the object that the prediction is dealing with, and checking to see, is the prediction correct? We're testing the prediction. We are either confirming the prediction or we are falsifying the prediction. If we go out and we look at the real world and we see that the prediction is correct, that's evidence that our assumption was correct. If we go out and we see that the observation is such that the prediction was incorrect, well, that's evidence that our assumption was incorrect. So when we test the prediction, we're actually testing the assumption because the assumption is tied directly to the prediction. Here's the way you can think about it. The entire calculator is a hypothesis. Like, let's take a look at one of Quantum Eraser's sample hypotheses, okay? All right, here's one. Check it out, okay? It has three pieces, right? It has the truth question, the independent variable, and the dependent variable. So let's see if we can describe the calculator in language that looks like it matches this. If the Earth is shaped like mainstream science says, then the farther away you move an object past the horizon from an observer, the more of the object will be obscured by curvature. Dependent variable, independent variable, truth question. So we have ourselves a valid hypothesis. Now remember, a hypothesis is a guess. It is speculation. It is, in a way, an assumption. You're saying, I hypothesize that this is true, but you don't know it is yet. I hypothesize that this is true, which implies tests that you can then perform to determine whether it is or is not actually true. That's what the calculator does. It assumes R, provides a prediction, and then we take the prediction to go out to find out whether or not we can test or falsify, confirm or falsify, whether our original assumption was good or bad. So of course we're assuming R. That's the whole point of the calculator. But the whole point of the calculator, the raison d'etre is for you to give it an assumed radius, and it will give you predictions based on that radius. And then you can take those predictions, go out into the real world, and discover whether or not your actual world has that radius. Not only, yes, so as I was saying, not only can you use an assumed value of R, you must use an assumed value of R. It makes no sense to use anything else. It defeats the entire purpose of the calculator. You have to use an assumed R. That's how the calculator works. So I just watched Nathan's most recent show, and oh my god, these guys are. I seriously think they're legitimately insane. Like how they can have so much certitude and so little humility when they know that they do not have expertise in this area, that they are not particularly good at math or these calculators or even really thinking in these kinds of dimensions. They know this is a weak spot for them, and yet they insist. They tell themselves, they rah-rah themselves up into being absolutely certain that they're right when they're actually absolutely wrong. It's we can see Ireland from the beach at St. Bees all over again. They are so caught up in their delusion. They're so convinced themselves that this rhetoric that they keep spitting out is correct that they aren't even able to process these arguments and these explanations that they're hearing. I mean, he said a lot of things. I guess this is my favorite. This is my favorite one. All right, let me just play it.
Why would it be that an astronaut's son doesn't want to account for perspective?
Oh, I don't know, Nathan. I mean, do you ever think that maybe it's because to do so would be to make a colossally idiotic mistake? I mean, do you ever think it's maybe the case that it'd be absolutely asinine to adjust the object size by the angular size right before you subtract out the hidden height? You ever think maybe to yourself, like, maybe, just maybe, you should actually try to understand how the calculator works before you start mouthing off the way you usually do? If you don't think those things, Nathan, you really, really should. Free advice, buddy. Less certitude, more humility.
Side elevation's the word you need, M. Scott Veach. Side elevation. Locally, that doesn't really mean... It's very vague, very weaselly.
It's not even side elevation.
Side elevation, so you remove perspective. So you deny reality. Locally, meaning perspective denial.
Oh my god, this is rich. Okay, no, Nathan, I actually do not mean side elevation, whatever the fuck that's supposed to mean. I said what I meant. It was the right word. And you know what, buddy? I promise you, the day that I need your advice on what word I meant to use, I swear to God I will tell you. Oh my god. Okay, so do you want to hear what your mistake is? Because I'll tell you. I will absolutely tell you what your mistake is, because I know what it is. In fact, you know what? Fuck it. Let's start from scratch. And let's see if I can teach you some things that evidently you weren't able to learn on your own. And you need to pay attention, Nathan, because if you don't understand the things I'm about to tell you, then you don't understand anything at all. And that goes for you too, Riley. Although, if I'm going to be completely honest, I guess I would say I'm a little bit less worried about you. But look, you're both making a mistake here. And you both need to pay attention because this is your opportunity. This is your chance to correct your mistake. All right, so the first thing that you guys need to understand and accept is that ultimately, when push comes to shove, the things that we perceive, the things that we see, all depend on light rays bouncing off an object and being reflected into our eyes. A light comes down, it hits the object, it bounces off and into our eyes, and that is when we see the point. If we're seeing the point, it means that a light ray has hit our eyes. If we don't see the point on the object, it means the light ray didn't hit our eyes. It's an if and only if relationship. That's how we see things. And so if we want to ultimately talk about, how much of an object do we see above the curve, how much of an object is hidden behind the curve, we can reframe that entire conversation in terms of light rays. We can say, what points on the object reflect light rays into our eye, and what points on the object do not? It's the same sort of question. It's the same sort of answer. And so let's run with that model for a second. Let's run with this light ray perspective so that I can demonstrate something very important to you. And so that means that if what we want to know is how much of an object we see versus how much of an object is hidden by the curve, then another way we can ask that question is, what points on the object, let's say it's a building, what points on the building reflect light into our eyes and what points do not? So let's take a look at that, okay? Let's actually kind of take a very close look at a ray of light and see what's happening. So we got a ray of light and it's coming in from the sun and it's headed towards this building, okay? Now the first question I need answered is, this ray of light coming in, will it intersect the building or not? Is it going to hit the building in order to bounce off of it or not? Now, in order to answer that question, what do I use for the height of the building? Before you answer that, let's say actually that we're on a planet with no people. We're on a planet that has no animals, no people whatsoever. I'm just asking you about a ray of light and a building, okay? Nothing else. I just want to know, is this ray of light going to hit the building or not? What height do I use for the building? Well, obviously I use the actual height, the geometric height, because there is no such thing as an angular size in this context. There's no people on the planet. There's nothing to be looking at this thing. Obviously, perspective cannot come into play here. I'm just trying to find out, does a ray of light intersect a building? Obviously, the only number that could possibly be relevant is the height, the actual height of the building. So let's say I find out that it does intersect the building. It bounces off, okay? And now it's going this way, and we're still on a planet with no people on it, no animals, no observers. And let's say this ray of light just happens to barely clear the Earth right here, okay? But we're still on a planet with no observers, which means that there's no way that angular size can have come into play for any of this. And the light is moving along, and then at the last second, I magic into existence a person, and I magic them into a spot such that the light hits their eyes, and they see the object. This is the moment in which perspective would matter. And what perspective can do is it might be able to take the things that I've seen and make their apparent size different, smaller. But what it cannot do is change what things that I've seen. Perspective cannot ever be responsible for causing me to not see something that I would have normally seen. The ray of light, it already hit my eyes. I've already seen the building. I've seen the building based on its actual height. The ray of light came in, it intersected the building based on its actual height. There's no way we could have done that based on the angular size, because there were no humans back when we did that. We only magicked this human into existence a minute ago. So obviously the only thing that could possibly make sense here is the actual height. This ray of light bounced off the actual height. It came traveling across the Earth. It happened to finally hit my eyes. And yes, now perspective can kick in, and that building may have an apparent size that's smaller, but I'll still see everything on the building based on the actual height. The part that I see cannot change. I can't undo my seeing because of perspective. I can't, by definition, the fact that the ray of light reached my eye means that it is impossible for that building to have be dropped down below the curve because of perspective. That cannot happen because a priori already I've seen the ray of light. I can't unsee it now. And this is a fundamental truth, a fundamental geometric, logical reality that you guys are not appreciating. You guys are not seeing it. You're not understanding how important it is. This tells you that you're wrong in trying to apply the angular size to the height of that building. If the ray of light hits it and the ray of light reaches my eye, that's all I need to know for whether I saw it or not. Perspective can change the apparent size of what I saw, but it cannot change what things that I actually saw. Please, guys, tell me you understand now.